All right. Yeah. Good day, everyone. How you guys doing? This is Bambi again. I used to spell my name at the beginning of every video. Yeah. Again, my name is Bambi. How you guys doing? So today we are going to continue from where we stopped about solving LEA question. So basically, today it will be kind of different from the usual one we do. Uh, yeah, a little bit simple. And then they actually wrote a math person, according to LEA, they wrote a math person for this question because they believe the question is not too tough. If you are actually very good with maths, you are fully going to understand what the question is all about, which is cool, right? So, this is how the question looks like. The question is like let me write that one x to the power of y minus y to the power of x equals to 17. So, whenever you want to solve any question, like I said before, the first thing that should come to your head is how do I simplify this question? Most especially when it comes to exponent. In a question like this, it can be a little bit tricky, but trust me, 1000%. There's no 1000% anyway. Trust me, 1000% that when it comes to mathematics, there's only the way out. Like they are complex questions, of course, but they are just tricky. Like you can always find your way around them. They are easy. Now, don't forget to like, share, and subscribe. I'm going to say that now, and I'm going to say that at the end of the video, so that I can keep reminding you to actually like, share, and subscribe on the page. That's going to help me a lot, and it's going to help us grow this community as fast as we can. You can reach out to Eddie at this email, murphyjacoby289 at gmail.com, and their number is 09129871317. And of course, on their telegram, 079035458782. And of course, they're actually running a free class by December 2, and trust me, it's going to be a top notch because I will be there as well. So, Learner's Edge Academy is one of the best places you can actually learn online. That's by the way. Now, let's talk about solving this question. How about we playing with numbers, like manipulating numbers, of course? If you manipulate number having x to the power of y all to the power of 1, obviously the 1 does not make any difference. Like the 1 is just there, it doesn't affect anything, nothing is going on, you just have your 1 there. That's how interesting mathematics it is actually. So you could do the same for y to the power of x or to the power of 1 equals 17. This makes sense, right? So we can further manipulate numbers again. Like I used to say, manipulating numbers. If you further manipulate number one more time, you're going to end up having something like x to the power of y all to the power of 2 over 2 minus y to the power of x all to the power of 2 over 2 equals to 17. Now, basically, 2 over 2 is the same thing as 1. So it's not the same thing. Like, I'm literally doing nothing. Can you see that? That's actually interesting, right? So, we could have x to the power of y. Now, we can apply some, basic math to that. 2 over 2 can be 2 times 1 over 2 minus y to the power of x all to the power of 2 times 1 over 2. And then, of course, it's going to be equals to 17. Right. So this particular law in exponents called the product rule that everything outside the brackets affects everything inside the bracket. So basically, what the law is saying is if you have a to the power of b all to the power of c times d, you can literally have a to the power of b times d all to the power of c, and then c can even come in, and then you have a to the power of b times c all to the power of what? D. Still the same thing, right? No difference. All right, let's now insert the same thing here and let's see what we got. So we can have x to the power of y times 1 over 2 all to the power of 2, not forgetting my 2 right there, and then we can have y to the power of x, all to the power of times 1 over 2, all to the power of 2 equals to 17. Now this actually makes sense. Like this actually makes sense. So I can just come down a little in order to be able to continue the question, of course. Now, y times 1 over 2 is obviously going to be x to the power of y over 2. And don't forget that your 2 is outside. And then, of course, y to the power of x over 2, all to the power of 2 is going to be equals to 17. Now, moving on. Don't mind the sign. Moving on. That's what I mean. So basically, looking at this, one thing that should be stuck in our head as a math person is difference of 2 squared. That is, a squared minus b squared can actually be equals to a plus b, a minus b. Like that's the law for difference of 2 squared, which means that 7 squared minus 5 squared is equals to 7 plus 5 and 7 minus 5. This makes sense, right? Yeah, that's how we do. So basically, we can put, our value in here using the same format, like literally math. Very interesting. Now, looking at it from this angle, I can say this is, x to the power of y over 2 using difference of 2 squared plus y to the power of x over 2. And then parenthesis x to the power of y over 2 minus y to the power of x over 2 equals to 17. All right, so we are getting to somewhere, right? Let's continue manipulating numbers. We could say x to the power of y over 2 all to the power of, oh, sorry, I already, expressed this, sorry. So plus y to the power of x over 2. And then we can have x to the power of y over 2 minus 5 y to the power of x over 2 equals to 17 times 1. 17 times 1 does not necessarily mean anything, because 17 times 1 is the same thing as 17. So I'm not doing anything literally. Now, like I used to promise that one day I'm going to compile a video all about algebra. Like I'm going to explain the basic things you need to know about algebra. So there's something called comparison in algebra, that you can compare number. Obviously, the positive one would be greater than the negative one. So let's start by comparing the both. If you compare this, you are going to have x to the power of y over 2 plus y to the power of x over 2 equals to 17. That's the first equation. And then you can have x to the power of y over 2 minus y to the power of x over 2 equals to 1. And that's equation 2. Now, here we are having something called a simultaneous equation. So we can decide to use an initial method. Of course, we can use substitution method here. We are having two equations. So, some people call it system of equation in SAT. Yeah, for Nigerians, we don't call it that. I think we call it something different entirely, which is actually simultaneous linear equation. Still the same thing, anyways. It's just math, the universal language. Let's start from adding the both sides together. Let's add this and this together. If you add the both, literally this is going to be off. Like, let me just put the stove there. This guy is going to be off. Like, I'm going to be left with adding the two together. Since they are the same thing, when you're adding the same algebra, you're going to end up having 2. For example, if you add a plus a, you're going to end up having 2a. If you add b plus b, you're going to end up having 2b. If you add c plus c, you're going to end up having 2c. Yeah, this actually makes a lot of sense, because I'm going to have 2x to the power of y over 2 equals to, when you add this, it's already off. When you add this and this, you're going to have 18. Now we can divide both sides by 2. Doing that, we are going to have x to the power of y over 2, and 18 over 2 is actually 9. Now, in order to be able to eliminate, remember, when it comes to you eliminating an exponent, you have to note that you find a way to actually raise both sides by the inverse of 1 over 2. You want to eliminate 2. The inverse of 1 over 2 is actually 2, so you raise both sides by 2. And this is actually going to take this out, and then we're going to have x to the power of y equals to 81. And this can be reduced, like you can find the index form, the exponent form, or let me just say the index form of x to the power of y is equals to 3 to the power of 4. Now, for a math person, obviously they will know the answer from here. Yeah, they will know what to do from here. But for someone that is not a math person, you'll be like, okay, what if we do it in a different way and we get a different answer? How do we know that x is equals to 3 and y is equals to 4 for sure? Why can't we just check? So this is a way of checking. x to the power of y over 2 plus y to the power of x over 2 equals to 17, that same equation, and x to the power of y over 2 minus y to the power of x over 2 equals to 1. Now, this time we are subtracting. When you subtract this and this, you are going to find out that this is going to be off. And when it is off, obviously, here's what you are going to do. Negative times negative is going to be positive, and positive this plus positive this is going to be 2y to the power of x over 2 equals to, when you subtract this and this, you're going to have 16. Now we can divide both sides by 2, and our value will be y to the power of x over 2 equals to 8. Now we can raise both sides by 2 like we did for x. So y to the power of x over 2 equals 8. Now we can square both sides. When you square both sides, you are going to end up having something like this. Y to the power of x equals 64. How can you reduce 64? 64 can be reduced to 4 to the power of 3. Now, arguably, some people are going to say, okay, fine. I can just say 64 is 2 to the power of 6. But looking at this kind of equation, we could do it that way as well, but it's best we do it this way. Now, if you look at the pattern, you are going to notice that the base here and the power here is x and y, and the base here is 3 and 4. But when the base was y and the power was 4, it was x. So we have 4 and 3 here as well. So it's a pattern. So we can therefore conclude that x is equals to 3 and y equals 4. Like having this kind of situation, x is already representing 3 and y is already representing 4 because it's at the power. And when it is here, it is 4, and when it is here, it's actually 3. I hope you all understand this. So, LEA question, according to the LEA question, I intentionally expand this just for you to be able to see the question better. Let me try to increase the size of this. Let me just try to increase the size so that you can actually see it better. Or white, you can see the name boldly now. Learners Edge Academy. You can go on to reverse the video to as much as possible to actually get what you're looking for. Again, you can see their number clearly, and you can message them on Telegram as well. And of course, you can always reach out to me. My name is Diophantine. For any challenge you have on academics, be it art, commercial, humanitarian, science, whatsoever, this is my WhatsApp number. And yeah, thank you very much, everyone. You can see that math is actually very easy, and any daily question is actually easy as well. Don't forget to actually go to LE if you have any academic issue, right from grade 1 till your college level. Thank you very much. Once again, my name is Diophantine. Have a good one. Goodbye, everyone.